So let's go in and configure our DHCP server. So we're going to move into config mode, and we start by creating a DHCP pool. So we use the command IP DHCP pool, and then it wants a name. What are we going to call this pool? Well, let's be fun and call it swimming. Swimming, but I do like to give it some type of identifier when I'm creating these pools to tell it what range of addresses or what network am I going to hand out addresses for. So we'll call this the DHCP pool of swimming 10.0.0.0 so that we know that we're handing it out to our 10.0.0.0/24 network. Next, that's going to change our prompt now to be DHCP. What I can do here now is I can say network and then say that it's network 10.0.0.0/24. And now it knows that it can hand out addresses on that 10.0.0.0 network. It's going to start handing them out at 10.0.0.1 unless my router's interface has the IP address of 10.0.0.1. Then it'll start handing out the addresses at 10.0.0.2. I'm going to show you how we can exclude some addresses there in just a moment. For now, just know that the very first address that we're going to hand out to a workstation will be 10.0.0.2 because if I do show run int f00, I've already used up 10.0.0.1 and my router knows that. Next, let's set our DNS server. So our DNS server, to do that, we simply say DNS-server, and then I'm going to point it to Google's at 8.8.8.8. If I want to configure a backup DNS server as well, I can do that, 8.8.4.4. Next, let's tell it what its default gateway is. Now, since the terminology gateway and router, no one on earth can seem to consistently use the terms. Windows uses gateway, Cisco uses gateway sometimes it uses router, sometimes it uses default gateway or default route, all kinds of things. Here, in order to tell the DHCP server what to hand out to the workstation for the default gateway, we use the command default router. So the default router command is going to specify the IP address that we would fill in the blank on our workstation, right? On this configuration page here. We go into this configuration page. When we configure the default router on our DHCP server, what we're doing is we're telling the DHCP server what value to fill in this space right here on the client. So in our case, that is 10.0.0.1. That is the default router for network 10.0.0.0. Excellent. We've given it a range of addresses. We have given it DNS servers. We've told it what the default router is. And we did specify the subnet mask that happened right here with the /24 when we told it what network it was on. So really, it was just these couple commands, the IP DHCP pool command, the network command that tells us what network to hand out the addresses for, the DNS server command, which tells the DHCP server what to configure the workstation's DNS servers for, and then our default router command. We can do one other thing here, and we can actually set the lease time. And the lease time is something we use in DHCP to determine how long a workstation will hold on to an address. The default for a Cisco router is 1 day or 24 hours. We can change that. We can change it to 1 to 365 days or infinite, meaning it can keep the address forever. That lease time is very similar to what you might think of as leasing an apartment for yourself or leasing a car. The idea behind the lease is that you make an agreement. If you're renting an apartment, you make an agreement and you say, I'll pay you this many dollars a month, and in return, you give me the apartment, and we'll agree to do that for a fixed period of time, maybe 12 months. At the end of 12 months, we get an option. If we were good tenants, we can maybe renew our lease and ask our landlord to re-sign a contract and give us the same rent at the same location for another 12 months. Or we have an option of terminating the lease and saying, I'm all done, and walk away. The lease in DHCP works very similar. The lease timer here just says, how long will the workstation be allowed to keep that address? It's going to determine how long that's going to maintain in the DHCP binding table. What will happen is the workstation will get that DHCP address, and inside of there it'll have a lease time. When half of the lease time expires on a Windows workstation, it will ask the DHCP server to renew the lease. If you want to learn more about all of this DHCP stuff and the leases and all kinds of craziness that can happen with DHCP, I highly recommend looking into my fundamental protocol analysis with Wireshark course, because I talk all about this in way more detail than we need to cover here. So if you have more interest in this, go check that out. For the time being, we're going to keep that default lease time at 1 day. Does it matter in this case what the lease time is? Not particularly. 24-hour lease time is just fine. So now we have our DHCP server configured. If I issue the command show IP DHCP binding, what that will do is it will show me this table of IP address to MAC address, as well as the lease expiration timer. Right now, I do not have any leases because my workstation is disconnected. So let me connect my workstation up to that switch. The switch is connected to the router right now. So once my workstation has a connection to the network where it can pass traffic, it's going to send out that DHCP discover message. Then after it gets the discover message, it's going to get an offer. Then the offer it'll reply to with a request, and then the server will respond to the request with that ACK. Once all that happens, we're going to have an IP address on our workstation, and we'll see that IP address show up in our DHCP binding table. I'm going to go to command prompt here, and let's see if we have an IP address yet. Issue IP config, and there we go, 10.0.0.2. And there's my router, 10.0.0.1. I can now ping my router, 10.0.0.1. Before I had that 169.254 address. After I set up my DHCP server, now I actually get a real address. If I look at my router and I do that show IP DHCP binding again, now we see that binding of 10.0.0.2, the address on my workstation now, along with a MAC address. So this MAC address should line up with the MAC address of my workstation. We can verify that. We'll do an IP config all here. If we scroll up, we'll see our hardware address right here, 000C29FC70A5. Looks like it adds a 01 in front of the MAC address here. This portion here is the MAC address of my workstation, and we have an IP address 10.0.0.2. Now, what happens if we have a network and the network has a server on it that has a fixed IP address, and that fixed IP address is always 10.0.0.10? And maybe we have another workstation on our network that always needs the IP address of 10.0.0.80. Well, in those cases, right now, what we would do is the DHCP server would just start handing out those addresses and not care that those addresses existed. So what I'm getting at is I already have a workstation on my network configured with 10.0.0.10 and 10.0.0.80. So what I can do is I can create something called the IP DHCP excluded address list. And to do this, all I have to do is tell it what addresses to exclude. So I say IP DHCP excluded address 10.0.0.10, 10.0.0.80. We can even make a list. IP DHCP excluded address maybe from 10.0.0.100 through 120. We don't want to hand out those addresses either. What am I doing here? 100. Let's do question mark. Oh, there we go. 10.0.0.120. I just entered the command wrong. So here we're specifying the first address in the range. Here we're specifying the second address in the range. And what that's saying is now in our DHCP server, we'll do a show run here. It's saying in our DHCP server, never hand out the address 10.0.0.10, never hand out the address 10.0.0.80, and never hand out the addresses 10.0.0.100 through 10.0.0.120. And we do this when we want to have specific addresses that maybe are static on the network or that never get handed out to workstations. We use that list of excluded addresses to accomplish that. Here we can see our DHCP server configuration, and it is set up just like we expected it to. That's how we set up DHCP on our router. What I'd like to do next is go take a look at how the DHCP helper address can be used to get access to a DHCP server that's not local on our subnet.